Okay, so here we have square root functions. We have f of x being the square root of x plus 2, and g of x being the square root of 3 minus x. And we're doing a composition f composed g of x. So we want f of g of x, and we're trying to find the domain. Okay, so let's start here with the parentheses, right? We would say the g of x, because it's inside the parentheses. We would say 3 minus x has to be greater than or equal to 0. That's one of our rules that we can't take the square root of a negative number. Okay, so then if I solve this, negative x is greater than or equal to negative 3, x is less than or equal to 3. Okay, now let's think about what that means, x being less than or equal to 3. It means that every time I put a number in here that's between negative infinity and 3, in fact, I can write that, negative infinity to 3, my output is always going to be bigger, greater than or equal to 0. So I'm going to say that g of x, my output, is always greater than or equal to 0. Well, what happens if I put a number in that's greater than or equal to 0 here? Well, if I put in 0, that's the smallest number, right? I have the square root of 2. That's okay, I can have the square root of 2. And if I put in any number bigger than 0, I'm going to get more positive in here because I'm just adding 2, right? So everything's going to be just fine. I can take the square root of all those numbers. So the restriction is actually right here. Now you're going to look in the textbook. They've done, if you look at the textbook, they've done something very odd on that problem. I don't agree with how they did it. So I've given it to you logically, how I can follow it. And that's the answer right there, okay? Because your outputs are going to be fine. You're adding 2. Now, what if it had been a different function? That'd be a different situation.